All right, I think we are live as usual. Let me just tweet the link to this stream and we're ready to go. All right, I had it prepared, so we're good to go. And let me just check YouTube. Yeah, you are live. Cool. So we are live and everything seems to be working fine. Okay, so welcome to the next installment of this design process for the Featherwing. I actually need a few minutes, I think, to see where did we end up last time, because I actually haven't looked at it that much since the last video, and that was some days ago. I don't know, like last week, no, 2 weeks ago. Yeah, something like that. So I think we were done with the schematics. We moved on, exactly, we moved on to the PCB here, and yeah, I did the outline, I did some of the footprints, I think I did 3D models as well. Let's see. Loading. Alright, yes. This model is so detailed. It doesn't have to really be, but it's nice to see it. Right, so this is where we ended last time. We have the outline. I need to move, I think the first thing I will do is actually move the display, because I run a poll on Twitter asking people which do they prefer, because there's two ways this LCD can be really positioned. It can be positioned as it is right now. Actually, it's perfectly, there we go, you can see here, it's like perfectly centered on the board. Hey Grogard, nice to have you. So yeah, the LCD right now is in the middle, but that means the active area of the display is like somewhere here-ish. So if you were to display something in the middle, it would not be like if you had some menu items that correspond to the buttons. If you centered it, it will not be exactly in the middle. So the other option was to move it slightly to the right, so the actual middle is in the middle. And that was actually the option that won on Twitter. So that's what we're gonna do. So we can get to it. And yeah, let me flip it. There we go. I can hide the rat's nest. There we go. I guess yeah, I don't have the outline for the active area here, but I think, or should I? Because I could do it like in the ballpark, but maybe that's not good enough. So to actually have it properly, I need the datasheet for this display, and then we can do all the math. So if we go to bydisplay.com, ay. Yeah, so this is actually where I'm getting these displays, and this is 2.6, I believe. Yeah, because at one point I was using a 2.8, but I think now it's the 2.6 one. Yeah, it's 2.6, all right. So it is exactly this one. Yeah, but this is supposed to be a bit project for the people, so I think might make sense to have it nice and centered to the active area. There, exactly. So this is the graphic we want. So what I can do here is draw it up. An image there. Right. This drawing actually doesn't show. Doesn't show the spacing here. Like it shows the active area here and then the visible area, I think that's called, but it doesn't actually show how this is offset, so that's not so great. Or am I missing something now? Yeah, that's actually a bit strange. So maybe can't exactly do it. Which is a bit strange actually, but let's try our best then. Right. So if I moved it exactly like this, what has to reload? Why? Alright, so now the outline is on top of the outline, so it doesn't quite work. This is really strange, actually. That drawing doesn't really show it very well. I could do like, it's actually quite centered right now. This is super scientific. I'm using a ruler on my screen and seeing where the middle is. So that's how you do science. So I think this is actually good enough, even if it's slightly off. There's still a there's still a bit of wiggle in the flex, so you can move it slightly to the sides anyway, and then even even inside the connector there's a bit of like slack. So I think this is quite alright. Oh, okay, I see what happened. I didn't move this one segment over here. Although it's still, yeah, it's not correct here. Right, so we align it here, and then here the arc itself is not so great. But now I think seriously it's gonna load every time. Is it because I press Alt 3? I mean, am I closing it? I don't know at this point. Yeah, so that looks quite alright, I think. No, I don't think I'm gonna widen the PCB actually, because I did a similar design before when it was an actual, not a feather wing, it was a proper board. And this worked. There was no problems really with this. I mean, I use double-sided tape to keep the LCD in place, and yeah, it stays in place. And since you're not really grabbing here, your hand is like in this area over here, and even your fingers on the back never really go there. So I think this is, oops, what did I press? Oh, I pressed some shortcut I didn't even know existed. Huh. Shift S or something? Apparently it's not visible here, but I hid SMD parts. Right, so I wanted to see the back. Yeah, exactly. So this is like, it's slightly out, but I think it's pretty alright. Okay, at this point I don't even know which am I using. Yeah, okay. So maybe if I move it this smidge, just the tiniest amount in the history of amounts. Yeah. Oh, I shouldn't have pressed Alt 3. Hi, Alex. Damn it, what happened here? I moved, right, I disconnected. I know what I did. Here, disconnected. Yep. I don't know. Alright, so now we have it pretty okay. Yeah, this flex is not super representative of the actual thing, so I don't worry about that. Right. Yeah, I was trying to rotate with shift and middle mouse because that's how it is in Fusion, and muscle memory is a thing. Alright, so the display is centered, so we're happy there. Did I put the whole... Yeah, okay, so that carried from the other design. So that's the hole for the microphone that's built inside the keyboard. So I think now we will place the feather because that decides a lot. And I actually ran another poll on Twitter asking people where should the feather go, because I mean you can have it like, I can show actually driving. You can have it like here, or you could have it somewhere here, or to this side, to this side. The problem is that if it's anywhere else really than here, like this is the area where your fingers go when you're holding the board, and you don't want to be touching those electronics. It's just not super comfortable. So I was happy with the poll results that people decided this is actually the best place to put it, and I pressed Alt 3, and yeah, this is where we are gonna put it. Right, did I have... I thought I had a feather somewhere here so I can like look exactly at this USB, where should it be, but I guess edge to edge is quite a ride. So we can do that now. Right. Now to the sides. There's not so much actual space here because either this connector is on top of that one or on top of this one, and neither can really be moved because of the flex cables here. So there's not a lot. Now what I have to decide is, do I want the board, the actual feather, to cover the hole over here? And if there's a case on the back, you want this exposed because you want to like have a screw going through it, so you don't want the feather in the way. So yeah, we will have to keep clearance there, but I can move it just a bit. Yeah, so I get similar distance here and here, because I mean this is supposed to be a 2-layer board, so there's gonna be a lot going on over here. And I mean, Alt 3 should stop pressing that. Like, you can route here, but you can't really place components under the flex because it will just not fit otherwise. Or you would have to put it like way in the back, not directly under, because this is where it starts going down to the connector. So there is some stuff that might have to fit, like over here, like the backlight control, which is just a SOT23, so that's fine. Alright, so the last thing before we start placing all the... Okay, actually two things. Alright, so we need to place the switch somewhere, and I think it's only natural to have it like here. Alright, I would say. Yeah, I think this should be fine. It actually, let's see, layers, no, not hidden text, rat's nest. So it's actually supposed to go to the enable, which is here. So yeah, the routing is right. It would be way worse if it was somewhere there. I think a lot will be decided by the actual, I mean, to ease out the routing, because it's not a lot of components, but it is pretty tightly in one place. So that's gonna suck slightly. Alright, so the switch... Oh, come on, I did Alt-Tab this time. So the switch will be over here, and you can... how does this look from this side? Yeah, it could be... because we have the SD card as well, and maybe SD card actually makes... No. I was thinking if it makes more sense here, but actually it has to be connected to the SPI, which is right there. We could actually do this. Yeah, I mean, an SD card connector is not much taller than like a QFN, and the connectors, these connectors will be way higher anyway. Like if you see here, I don't know, it's annoying. I mean, it might not be this high because these are the standard height connectors, and I'm trying to look into half height because this is just ridiculously high, tall. But the problem is, like even if these female connectors here are half height, you still get this standoff on the male side here, or you could remove it. Like you could do some tricks here to get as low profile as possible, but I think pretty much no trick will make it so it's so thin that it would actually have a problem with the micro SD. So I think it might make sense to actually have it there. I don't know. I don't see why that wouldn't work. Could have it here also, so it's right next. Could that fit? I think it could. I'm just getting fooled by this here, but that's on the other side. So that shouldn't be a problem, really. Yeah, except the flex is over here, so that is a bit of a problem. Okay, so what alternatives do we have? Could have it, no, not here because of the flex over here, and not here really because we are really actually out of options. Yeah. Okay. Let's have it. And this connector, you can see I have the outline of the board of the card also in it. So it's actually pretty small, and then the card goes out quite a lot. So we have to have it a bit in. Right. Yeah. What I think you could do, I'm not sure if I have it. Oh, this one. If I have there we go, the model for the SD card, yeah, it's super simple. So you can actually, where the heck? So you can actually position it inside the connector and see how it looks, how much it goes outside. Oh, this model is not centered at all. Right, at least on this axis, on Z, it's alright. So if we align this sector here, it should pop up any minute now. Yeah. And then how much do we want it to actually go out? Guess can make it flush with the board, and then you have some opening, so you can pull it out like in a Raspberry Pi, or you could have it. Yeah, I think we make it flush actually. All right. Yeah. So that's that one, and I can lock it actually in place. These things should not be moved by mistake. Speaking of, this was moved by mistake. All right. So oh man, this is gonna be super tight. I mean, this is convenient. It just goes here. But right. Oh yeah, that's the silk for the whole module. This is the axle, so it's gonna go somewhere. That's for sure. It goes to the I2C. Oh no, this is a right. That's the touch controller slash GPIO expander. So this could actually go somewhere here because no, not this one. The axle you kind of want actually like close to the middle of the board, so then yeah, when you tilt it, it actually makes sense. And that one is actually, oh yeah, here, the tiniest of tiny. Yeah, this one is I2C. So this, yeah, the I2C is here. So this is really quite good. Something like that. If we place it somewhere here, let's, yeah, sure, why not? Right, it's gonna be like here. Yeah, this tiny thing. And then it means it's the coupling and all that. Yeah, I'm thinking this might actually make sense here because the touch stuff is right here. So you want these to go directly in here. And then the backlight controller is here. The keyboard interrupts. Yeah, this is quite alright. 1, 2, 3, 4, yeah. Let's just go somewhere here. And last is the big one, which has to go here because this is the keyboard one, so it will go, everything will go to this connector, so it has to be here. I'm actually worried if we can fit all the pins here, it will be quite messy. The backlight is actually just a MOSFET that I'm gonna toggle with PVM. Then for touch, this is resistive touch. I actually borrowed a chip that the Adafruit LCD Featherwing has. It's the not this. Oh, where was it now? Did I not move it yet? Wait, where did I put it? Well, I lost it. It's the STMPE8, like they use 620, but 811 seems to be pretty much the same one. So it's a GPIO expander that also you can use as a resistive touch controller. And the nice thing is that CircuitPython already has support for it. And I think the Arduino libraries from Adafruit also. So I'm trying to use things that they use just so I have to, do as little software work as possible. Yeah, the axle is I2C here. Yeah, like it's SPI because they also use SPI, so I just wanted to copy those things. Okay, let's see. Man, this is gonna be quite messy. Maybe I did it somewhere here. It's quite far from home. Like I haven't assigned any pins because that part is very flexible over here, so I can use whatever fits best. But yeah. Hi, Benjamin. Well, the OS is you choose your own. Like it is a Featherwing, so it doesn't have any like a main microcontroller of its own. So you could put the I don't know, one of those Featherwings that support CircuitPython. Then you can just use CircuitPython for it, and I will write a CircuitPython module for the keyboard, so that will work. And then everything else on this board is already supported by CircuitPython, like the SD card, the axle, the touch, the display. It's already works in CircuitPython. You could use some Atmega or something and then run Arduino code on it. And I think, again, everything except the keyboard is already supported because all these components are like similar to what Adafruit boards use. And if you want to go hardcore, you can use Grogard's giant board, run Linux on it. Then I think also most things should work. Grogard can say more about that, what works on his board. And yeah, Greg Davil is working on and off on an FPGA feather. So when he's done with that, you could connect even that one here and just go crazy with Verilog or whatever is your poison. So that's the kind of cool thing about this feather wing, that it is independent and you can use whatever works best for you. Right, what was the problem there again? Yeah, so I have to do this because I use the double header thing, which is also something I inspired by Adafruit's LCD feather wing. It's quite nice because even if you put the feather, you still have access to all the pins from the feather, so you could just use you know, jumper wires to get any GPIO very easily. You just plug in and you're good to go. So you don't need like these long pin headers on the feather, or something soldered on top, or wires or anything. So I really like this, and I think it's worth sacrificing a bit of space to have this functionality. But yeah, that is forcing me to do this over here. Except what the hell is happening here? Here's a question. Huh. I have no idea. There's so many things I'm not sure what to start with. I guess I should place the decoupling stuff. Right, so we have this buffer chip over here that's used for the NeoPixel, and the way it works is the NeoPixel needs 5-volt logic, and obviously the feathers are 3 volts, so you need this. You use this buffer to just, it's a 1-bit level shifter pretty much, or exactly. So it seems this is not on the grid. So that's not so nice. Still, Oh, I see the problem. Seriously. Yeah, the default footprint from Kicad doesn't really have, like, see the why is the indicator here on the pin 3? I want it on pin 1, or is that where the chip is actually? You know what? Now that I thought about it for a second, maybe I don't need that extra thing there. No, so the chip, this triangular thing, is on pin 1. So that's not where it is. Yeah, that footprint from Kicad is a bit strange. So that's why I put this extra here to know where that's going. Right, so I'm trying to place this buffer in some logical position. Yeah, I shouldn't put a VI in pad. Right. And then the NeoPixel that comes through. Yeah, there's a jumper. There's a bridge that you can always cut. So that's why this rat's nest was going to a strange place. So this is on the front, right? So I think it should actually be, oh no, this is on the back. So we can place it just over here. Because if it was on the front, it should be under the display so it doesn't look ugly. But if it's on the back, it can be here because the display is not here. Yeah, I'm not sure this is going fairly slow. I don't think I'm gonna be able to finish this today. Oh well. Slowly forward. See, something is strange over here. It was the same problem there. There isn't a keep out. Why is the what? YouTube is not displaying. I have no idea. Is anybody else having this problem? That it's purple and gray? Is it my video or is it just Andy Mouse's strangeness? Hey, Space Hun. How do you pronounce that? Hun? So right now I'm fighting Kicad that's behaving strangely. What is... It's not on the board outline. That's a way. So I can do... See, like... I had a problem once that... no, it wasn't the drill, it was the... Yeah, let's actually delete this. Yeah, I had this problem before that somehow... oh, what's the word? The arch here, the circle, the arc. The arc seems to bug out and Kicad thinks it's a full circle and the keep out is on the full circle of the arc. But I thought that was fixed way back. So right now to actually get around this, I can just do this, but that's super silly. So yes, I know I'm doing like almost 10 mil traces right now, and I won't be able to do this here, but I think for these, that's quite alright. So like, it doesn't really matter at this point. So we will have ground here, so we don't wanna ruin it too much. And yeah, maybe it should be thicker than 10 mil, but it's just one NeoPixel. Yes, I can put this back, but that... Was that the problem there? Yeah, that's not right at all, is it? Right, yeah, okay, there's a edge. Yeah, there's an edge cut there. Sorry I'm a bit like slow today, but I'm on so little sleep recently. Haven't recovered still since Berlin Make a Fair. That's why I don't think I'm gonna be able to finish this today, but we're making progress. Right, so we had the, where were we? The NeoPixel. Yeah, it has all this nice stuff here. And then the 5 volt is actually only used in this one place. So the diodes can be somewhere over here as well, I think. And what the diodes do, if you're curious, is they, again, since the NeoPixel usually works on 5-ish voltage, we want to supply that into the NeoPixel. But we don't know where it's gonna come from. It might come from the USB or from the battery, and you don't want, when you connect both, you don't want the USB going here and back into the battery like directly. That's a big no-no. So the diodes make sure it goes only one way, but we still have the option to use either. Hi Jovan. Hopefully that's how you say that. Right, so we have all this free space here. See, I'm getting confused by the back, the extra fluff, like the back footprints and everything is making me think there's way less space here than there actually is. So the 5 volt is here. We can have it somewhere over here. And then we need the battery, which is all the way there, and the V-bus, which is all the way over there. That's gonna be annoying. So let's not do that right now. The reason, because you still want to, like, the battery can do 4.2 volts, I think, when it's full, and then it goes down to like 3.6. So, and that's apparently good enough for the NeoPixel. So this is, again, this is lifted from another Featherwing, where Adafruit also did this, and seems to work for them. So we do similar here. So you can still run the NeoPixel from the battery as well. So we have the enable here, and that's again all the way like here. All right, this has to refresh. The problem with having all the 3D models is that they take really long to actually load and render, especially that feather one. It's so detailed, like it's way too detailed. But that's why Adafruit like offers you to download, so I went for that one. So we have this tiny corner covered over here. Then right, the card CS we will need somewhere here, so we could put it here actually. So that's this one. I'm quite happy that Kicad finally added a footprint for the. Actually, let's do it like this. For for solder bridges. Like way back when I first started using Kicad, you had to make your own, and I mean, it was only a one-time thing, but still it was non-standard. Now they have their own, so that's nice. And they have normally open, normally closed, and like a triple where you can do 1 and 2 or 2 and 3. That's kind of cool. So that's quite nice of them. Again, this arc over here is being annoying. I think we can actually, because it took me quite a while to realize why that was happening. And you can see, yeah, when you highlight collisions, right? Like you can see where this is happening, and it's, yeah, it's this strange circle that's pretty much exactly like that arc. So yeah, so that's really annoying. I guess I can do like this ish. Nope, still doesn't allow you, even if it only highlights. It will not allow you to do it. So that's really annoying. So we move it. Yeah, I had that in like before 5 in some 4 something version, and now it's back. So that's really strange. Does that one have a pull-up on it? It should. Yeah, there it is. Give me that pull-up. Could actually have it like here. I need to remember to add a silk screen for all these because it will not be so obvious without that. Yeah, because I removed the thing. Oh, right, now it's now it's under there. That's quite alright, I think. Still thinking mechanically, if there's a hole here, this shouldn't be in the way, so yeah. Yeah, highlight mode is, I mean, you saw how it works. It's not super great. Like, usually it's not so bad because it will only highlight the traces. But apparently, like a circle is just a lot of short traces. At least that's how the collision looked like. But normally you would only see the paths highlighted and so on. So it's a bit better. But yeah, walk around or yeah, shove sometimes is useful as well. Right, so this could actually... Where do we have 3 volt? Way over there. So that's gonna be, you know... Whoa. Right, so this will have to go here, and then the mossy is screwed, so that's cool. Yeah, there's no... Yeah, there's no good way around that. I will probably do the via on the 3 volt rather than on the mossy. Oh, that's very wrong. Something like that. Yeah, and that one has to go all the way there, and you would think this is fine, but it probably isn't, so let's do it anyway and then deal with the consequences as they go. I really don't, like, I feel uncomfortable somehow with long traces because I'm so used to working on tiny boards when everything is super packed. So like when I see this long trace, it makes me somehow uncomfortable. Just, it doesn't look right. I don't know why. All right, so I should be able, yeah. Yeah, I might make the power traces later thicker. I'll think about it. Right. What was next? We have this one, and it has a pull-up, so we can take that. Pin 6. And then pull up on the CS right over. Nice. Yeah, so for now I hide all the labels, as you can see, but I might unhide them later when I'm reorganizing the stuff. Yeah, I'm trying definitely to route this on a 2-layer only. I did manage to do it before with the original design for this, although it was not so packed in one place. So it might be a bit of a challenge, but I think it should be doable. Might just need some gymnastics. But where's the fun in that if you just do 4 layers? That's easy mode, surprisingly. I really want this bend over here. Yeah, this should still be able to walk out. That one, although not so much. So we have to move it a bit. I really don't want the. I want the traces always to come on the like short side of the pin. I don't want it going like a T shaped over here or something at an angle. I want them straight out. So that's why I moved the capacitor here slightly. Oh. Yeah, grounding will be interesting for sure. Let's see. I mean, I think a lot of the which side is it? Like if this is the front, then the back, the place where the keyboard actually goes, that will be mostly ground all around. So if I stitch it correctly, I think it should be fine. I will actually do that. Yeah, that's a good idea right there. I mean, right now it leaks out, but otherwise it's quite alright, I think. Yeah, why is my board blue? I think I was testing some other board and wanted it to be blue. I will probably go with this one for matte black just because it looks so cool. Oh, even though it's super crappy to debug because you can't see anything. So the solder mask. I guess we want good old PCB green. Yeah, there we go. Yeah, the clearance right now is ridiculous. Come on. Okay, why? What? Why can't I select it? That was strange. You used to be able to select it based on just the outline. I need a cheat sheet. 6 mil is how much? It's like 18. Right. That should fill up nicely now. Yeah, there we go. So back here, now we place these two over here. I need oh yeah, that's nice. The STM CS probably has a, yep, jumper, so we can take that, put it there also next to it. Oh yeah, I should increase the grid. How close can you get without it getting annoying? I haven't used that footprint before, so I'm not 100% sure. But this looks quite alright, I think. So this might actually be too far. It could be right under it, which I might actually change in a second. Cool. Sometimes Kicad's courtyards are quite annoying. I want to copy, I want to cut it. Because I think they're too big sometimes, somehow. Okay, so that didn't quite work as I wanted. I thought if I paste it's gonna just go back where it was. Yeah, so even see how far this is, so far. And the courtyards now are right next to each other. This works. So we can hide this one. Move on, so that's done. Card STM LCD. I guess we can do the LCD as well. I have no idea where it will go because it can't be on this, it has to be above. Or maybe below, yeah. Yeah, let's see. Because above the LCD I will probably put, or actually, you know, might be okay if it's under, because I will answer that question in a second. Because if you're breaking this jumper, that means you don't want to use the LCD, so it's not there, so it's fine to have it hidden under. But maybe you want to cut it just to use and still have the LCD, and yeah, it should probably not be, but it could be like actually here-ish. Or maybe no, this side is better because it has to go right here anyway. So if we put it next to each other, that might be fun. It just has to go all the way here. Why not directly? I actually made a board before that was this and an RF52840 Bluetooth module, and the problem there is, like, I'm locking myself and others, if I were to sell that board, to that specific module, and that's just not as much fun as the Feather. The Feather is now, it has become, I believe, like a standard that many boards are made in, like Grogard can tell you, and there's so many Feather wings that you can very easily use, and people are making more, and people are making custom feathers, and just using, it's like using the Arduino Shield standard. You just get so much for free. And exactly, there are ESP32 and ESP8266 feathers, so you can just very easily put it in the header and just go crazy. And then I saw someone on Twitter was asking, it was, let me see, Tommy Thorne was asking, I can just read it. Couldn't one connect the feather wing directly without the connectors, and thus keeping it completely flush, PCB on PCB? It wouldn't be hot pluggable? Of course it wouldn't be hot pluggable. And the answer is yeah, you can definitely do that, except I'm actually making it definitely harder right now because I'm putting parts under the feather. So you might need tiny amount of actually space, so you can't solder directly. But if you used some, I don't know, some pins, like short pins, and just solder the pins directly to these pads over here, you can do that, and that should be fairly stable, I think. Yeah, I will publish the Kicad files once, like I verify this and I get some produced. Yeah, it's gonna be open source hardware and software. Like I have some software already on GitHub for the keyboard controller. It's not exactly this chip, it's a smaller version of this chip, but I think it should work almost with no changes. Like it's just more pins, so I have to add those pins. I guess so, but that's another daughter board to raise it. Possibly. There's options. I'm sure if someone wants it, they will get it to work. I'm just thinking, actually now, Grogard, on your board, on this side, on the bottom of the feather, you have the the micro SD, right? I think it's like over here on the bottom side. So that would be a bit problematic if you wanted it flash. Like a lot of feathers I've seen, I think, are just one-sided, at least from other fruits. Maybe the ones people do can be double-sided load, and that then gets a bit in the way. But I don't think any of them are like millimeters, oh, well, like centimeters thick, 5 millimeters or something. So it should still be fine. Again, the headers will be the defining the height. It should be fine, I think. There's really not much, like, I'm quite limited here. Like, I don't want to make the board taller because right now I believe it's exactly 10 centimeters and I don't want to cross that number for PCB price reasons. So there we go. Yeah, see, it's exactly, well, it shows 100 in the rat's nest, but it is exactly 10, so I don't want it any taller. And then for the width, it wouldn't really help much because everything is like in the center and you can't move these holes too much, so it's not gonna help. Ultra low profile, I wonder if that's the ones that someone linked before. Checking that link. Yeah, that's similar to something I was looking at. The problem is, like, these are like €3 for one, which is so expensive just relatively to all the other things. Like half of this board, this components is €3 total. And do they are they? I didn't actually see that. Oh yeah, okay, that render doesn't really show it. So I'm guessing they have some pegs that have to go into the board. I mean, you can always file that, like sand it off, cut it off, but yeah. Yeah, it's the connectors are SMD connectors are for some reason quite expensive compared to regular connectors. I don't know if I don't know, low demand for them. It's not like it's more plastic or metal really, like the materials. It just has to be low demand. Right, there's right now literally nothing connecting the two ground planes, and I believe that's what this is. So let's slap a via there in a random place. Only I could. Seriously. Okay, that's another way to make a via. Why is my Kicad bugging out so much? This is quite unusual, and this is a stable build because I had some like release build. Right, the gold plating. Yeah, I don't know. Charlotten, do you think you could find a price or no? So I'm quite, if you could look for the price, I'm quite interested now, or I'm curious for sure. AliExpress, yeah, that works. Let me just check the link. 100 pieces. Damn. But these are 2 millimeters, so that's not quite. Yeah, these it has to be 254 millimeters. So this is it's something for sure. It's like I need like 2 by 14. That's that's $19 for 100. That's super cheap actually. But yeah, I need 254. So close. No worries. It's easy to overlook if you like don't pay super close attention. And I've done it many times, like order the wrong page and so on. It's common. Yeah, exactly, Gogard. I guess my audio is delayed. Where were we? We were placing components. So LCDCS, I decided to put it here, and that's all right. It's gonna be one long trace. Yeah, I'm gonna I need space for these, but probably not this much. But this is just for fun. Yes, I know I will need something like that here. And then the DC goes places. It goes there. Right. So we could actually put it here also, and then we have so many nice all the which grid was I on? This grid. Yeah, this way all these jumpers are next to each other, so that's quite nice actually, I think. Yeah. This 3D model looks strange. It looks like crumpled, which was not... I wasn't trying to make it look like that, but looks like some shading issues there. But really nice. We have 8 viewers, which is super nice. Thanks everybody for watching and hanging out with me, which is the point of these streams. Like, I mean, this isn't like... I'm not really teaching Kicad. You can always ask me if you have any questions, and I'm trying to say random things why I'm doing them. But the reason for these streams for me is that I just like want to talk with people and hang out with them while I'm doing these designs. So it's cool that people join and watch. So I hope you're having fun hanging out. What's happening here? Right. The minimum width is too large, too thick. Is this enough? It's not enough. I really don't want to make it too thin because then we get to strange situations. But actually, I mean, I can very easily fix this doing like this or doing like this, which actually you should do because... Oh wait, these are all... Oh, I see the problem. They're all connected together, but they're not connected to any actual ground to the sides, which is just strange. I think it might be also these thermal reliefs, I think it's called. Yeah. The thermal clearance. Yeah, what was this setting? I remember. Was that not it? No. There was one setting where you could have a quite cool roundness. Oh well. Yeah, this is fine. We'll deal with that later. So, right. Yes. Now we're here. Right, so now we have all the jumper wires. Okay. Then the keyboard and the axle, the I2C. Could put it just here. Yeah, let's just move them at least closer. Test pads, test points will be also a bit annoying. I made them extra big. Alright, so we have the SDA. I mean, this will be something like just like this pretty much. And then for this one we need that's not the nicest actually. Could have it on this side. Except, are they at the same exact point? Nope. Okay, now they are, I believe. Yeah, so what you just saw me did is actually, because you can see, well, now it wants to, but Kicad was being grumpy and didn't want to have a perfect 90 degrees connection, like it was doing something strange to the side. So what I found out is to force Kicad to do this, you just do a via, like you toggle a via, and that will force it to go 90 degrees. Oh, see it now, like I cannot, but if I do a via, there we go. Sure, Max, I can talk about, it's gonna be kind of boring because this board is not very, it's not very ambitious in its part choices, let's say that, but I can talk about it. Just let me do, so I know this is silly, but what I like to do is if I have a 90 degree, I like to have this nice junction so it looks better, I think, which is silly. So for LDOs, for example, I mean, LDOs are fairly easy to choose. They only have, like, obviously you need the voltage that you want to get out of it. So there's actually no LDO here because it's on the feather, but like you need to know what goes in, and that can be a range from, like, let's say from 5 to 9 volt, and then out you need at 3 volts. So you search for that. I usually use Mouser and it's filtering. Exactly. So first voltage, then you have to know the ballpark range of how much current you're gonna need. I mean, you could go like just 3 amps and that's enough for everybody, right? No, so yeah, it makes sense to not go like if you know you're gonna use 100, it makes sense to use like 250 or 500 milliamps and not 3 amps, just because of the size. Like a 3 amp LDO is gonna be usually larger because it has more temperature to dissipate, or energy. What's it called? Energy to dissipate. So you just have to know what you need, and for those you have to read data sheets and specs and so on. So once you have those 3 things, like voltage in, voltage out, and then current, the last thing, well, in a short version, is you want to know the dropout voltage, which is how do I explain this? Like how it's the difference, I guess, between the in and out. So like if you had 4 volts in, but you need 3.3 out, and the dropout voltage is 2, then that just wouldn't work, because the most you can get from 4 with a drop of 2 is 2. So you have to make sure that it will just allow you physically to drop the voltage from your input to output. And that's kind of it. And then you might want to look like how many components it needs. Like, is it just like decoupling? How many? Some of them are variable, so they need resistors to set the actual voltage. Battery power, yeah, exactly, that's true. That with battery power, you have to make sure that even at the lowest, almost empty battery, you will still have enough to supply for the output voltage that you want. And it's kind of like that with everything. Let me scroll. What did you? About components. Yeah, and many components here I actually chose based on already existing Adafruit feathers. So that's the boring part here. That like this what's it called? This buffer here, or it's actually an inverter, I guess. This buffer here, it's based on the feather, and this touch display driver is based on a feather. This accelerometer. But you have to, for these kind of things, like for the expander, you have to know how many you need. So like this one has 8. So I use 3 here, 4 here, and then 1 more is here, which I don't use. Then you want to know if you want to use SPI or do you want to use I2C. So that will define your choice. And that's, that's kind of it. And then from the hardware perspective, from the software, it's also quite useful to check if it's already supported in whatever you're gonna use it with. Like if you're gonna use it with Arduino, it's cool to see if there's already support. There's a library for that part, because you don't want to always, depends how lazy you are really. Like if there's a library, you just drop it, you have it. If you want to write your own, sure, but maybe that's, you don't want to spend all the time on just writing software. So maybe you want to use, sometimes might be even better to pay slightly more but already have the software ready, right? Like if it's supported by the Linux kernel or something like that. So it makes sense. And that's kind of what you do. Yeah, exactly. And you start a project and then you realize, shit, this has become more of a driver. Like I'm writing so much software, this was supposed to be about hardware, and you get discouraged. So that's definitely a factor. And yeah, that's kind of it. You just have to know your requirements, which is not always easy. I'm not saying it's easy. It comes with experience. And after some time, I think you build up like a library of your favorite parts, and that's just your go-to, even if it's not exactly within spec, like it provides, like an LDO provides more current that you really need, but you have like 100 of them at in your workshop, then you will just go for that one. Okay, I'm gonna go back to Kicad because why not? Because that's what the title says. But yeah, that's kind of it. Gorgard, anything to add? Where were we? We were here, right? I wanted to see if these resistors look alright. Yep. So here be voltage. Whoa, that's a big looking V. That this chip is so tiny that it makes everything look huge. Huge. Whoa. I'm sure that's fine. Right. Yeah, exactly. Like you get lazy with your part selection. Unless it's a new chip or something you wanna just try, but you just have your go-to parts. Oh, this looks quite nice. Alright, the clearance is, or not the clearance, the minimum width is good enough to actually work with this chip, so that's cool. The heck does that go? Right, there's some decoupling over there. Yeah, so we should get on that. Yeah. 10, 9. This tiny axle has so much decoupling, that's crazy. Like, seriously, the surface area of these caps is more than the actual axle itself, but got a decap. See, we can put some here and some here. Number 5. Yeah, exactly. So with Linux, I definitely, that's exactly, I do the same. That first thing I do is, does this have kernel support? Because I'm not writing a driver, at least unless I'm really have to. And not because it's like not fun or hard, but it just consumes time away from the thing that you were actually trying to achieve. And that happens a lot. Nine, 10. 7 is right. 2 and 3. Okay. Then 12. Where is 12 actually? Okay, there. So this is all, these two are just test points. I can put them here. Gonna be busy area over here. Yes, that is correct. About the families. So 6, 7, 8. 6, 7, 8. Yep. The good part here is that this single component has so many, see how little is left actually, just by doing this one axle and just by placing all the decouplings. Man, these test pads are gonna be huge. Yup, look at this crap. Oh no. On the plus side, I can just have them go somewhere here and then decide where they actually go in a second. So 12, 7, that's like way over there. So for that, damn, that's a big via, and it probably doesn't have to be so big. I need more window. Yeah, the annoying thing is when they are from the same family but actually don't use the same protocol, because it's more of a marketing thing, the family part, than actual. They're not really related, and it's even more fun when you find out about that after wasting a week trying to get it to work. Not that I ever did that. No. Right, so there we go. It looks a lot better like this. Right, you know what? Let's get rid of this one for this moment. The thing here is I placed this fairly arbitrarily just here. I should be able to move it ever so slightly. See, now that gives us so much more space. And this should be rotated because this goes. Yeah, right. So if we can squeeze in a via somewhere here, we can just go around. Yeah, I'm definitely saving. Like every time I see Kicad like kinda have a hiccup, I'm like, oh, okay, save. I think you can see it like, yeah, Control S. You can see it in the stream. Because it's not that it crashes, but yeah, it does. That's not so great. Now is it? I'm always torn between good placement and good layout. And by that I mean good placement. What I think is if you have all like this kind of thing, that all the components are kind of next to each other, because it looks really cool on when the actual PCB is done. You just have a row, and it's really easy also to solder them, because you just solder next to each other. You don't have to rotate. Um, and the good routing obviously is even more important, because decoupling should be as close to the chip as possible. So this is always like a fight between being I don't know, electrically correct and aesthetically correct. Let's call it that. But I think, like, I was starting to create vias here just so I can have that capacitor there. Yeah, it's not worth it. And I'm sure I'm not the only person who has these problems. Ah, no, this pump over here. No, so right now I'm still on the stable release. I haven't updated. Like, I haven't had time to update and check that it actually works, because if it doesn't, then I will have to uninstall and go back to the stable. So that was just too much work today. And this works mostly, like, except for that one bug that we just saw. So we can do constructs like this. But it doesn't look so good. Exactly, and just placing components randomly and drawing traces until things are connected, it's easy. But doing it correctly, it's an art. Like, I've seen some boards are so well, like, done, they're just designed, because they look great and they still manage to follow all the rules, and that's the goal, that's the dream. Like, I don't know. At this point, I could have just a plane of ground of 3 volts here, but it's not really needed. So, right. Yeah, I closed the window, that's why it's so quiet. Because last stream we had like street racers on the streets here. So that was a bit crazy. See, now I'm gonna spend 15 minutes thinking about where should I put this capacitor. Is this alright? I guess if I moved it just a smidge up, there would be ground fill over here. Like this. Hooray, now I have this fill over here. Yeah, I guess this is fine. I'm not sure. That's just strange. Because theoretically, see, like, this is actually not designed. Now that I think about it, this is not really designed that properly. Because from what I've read, the decoupling, like, 3 volt should go through the decoupling and then into the board. And if I'm gonna supply the voltage from here, then it goes in, and goes out, and it goes into the decoupling. And that like kind of, that's not like, it's breaking the rules quite hard. So what I should do is actually, I should have the voltage in on this side. But I don't know. Am I actually... Man, this is annoying. Like, just do it. So was that hard? I think it makes more sense to have the voltage coming like somewhere here, because this way, yeah, you have the pull-ups, and this way it goes here. Yeah, now I'm not sure anymore. Yeah, for sure. Like it's, if you're not streaming, that's the things you don't really see. Like if not watching someone, that you have to actually fix it and fix it. It's not all glamour. Now I have 3 volt here and there, and I have to connect them, and there's a 3 volt there, and has to somehow connect to that one. So the voltage here is gonna be nice, and it's gonna be crazy. Right, we have pads over here, as you can see. So let's not worry about that one. Should worry a bit about these 3, because they have to go there somehow. Don't even get me started here. This is gonna be a slaughterhouse, a bloodbath. So for now, let's say this is fine. We'll worry when we get there. At the test points I could actually connect-ish. I wish there was a button to just hide everything from the back. It's not an option right now. Right, so there's one. Another, and the third one. That's annoying. Oh, that's just sad. That worked out. Pads back, yeah, exactly. So this has to go like somewhere here. Like I know people say no VIA in pads, but actually VIA in test points is quite nice, because the tip of your multimeter probe can like get in that VIA, and it's stable, so it doesn't just go around. So that's actually quite nice. I don't do it on purpose, but if it's there, I don't mind it. I could do it on purpose if only the VIA tool worked. Yeah. So this pin 7, is what now? Yeah, it's the interrupt. Yeah, this is all data ready and interrupts, which you have to enable over registers anyway, so it won't. Because I was worrying that it's going under, and that might be annoying for the accuracy and noise and blah blah blah, but it's only really a problem if you make it a problem. No, you know what? Actually, I will go here because these will go there. Yeah, that works. So these will have to go all the way around over here. Yeah, that might be fine. Also this one and this one. It's gonna be fun. Effectively, these buttons will cut this whole board like almost in half with these long wires here. So we're gonna stitch it up. All right, so we have these. We could do, we have these and these. Let's switch. That's an option, but actually, didn't I place these already? Yeah, 1 and 2, right. And this one, okay, so we placed all the passives on this one. And then for the keyboard, there's only, exactly, well, there's this guy. From pad 2, so it has to be actually somewhere here. Yeah, this 10 mil is way too big for these, so these are gonna be thinner. But let's not get there yet. We can at least place. This is the backlight, as I mentioned. Right, plugged VS. Yeah, I never really looked into that. I just try to avoid it, or if it's there, it's not such big of a deal for passives. Like for VGAs and such, you definitely want the plugged VS so it doesn't, the VIA doesn't steal all your solder. But for passives, it usually just works. Right, so this is the backlight for the keyboard, and I did this before, so I know it works quite well. Just over here. Yes, I want it centered. Yeah, there we go. So now it's centered with the connector. So what I did there is I did move, and then I pressed space to reset the local coordinates, and then I can move this one to match. That's what happened there. Ooh, I hope there's no wires or traces going there. It's too thick. Yeah, so that's gonna be the MOSFET for the connector. Where does this go? That goes nowhere? Wait, what? Oh yeah, wait. It goes into the SAMD. Well, it doesn't go right now, but I will. Yeah, because you use I2C also to control the backlight. So it's the SAMD doing the PVM, and you just change the intensity. So you offload the PVM to the SAMD, so you don't have to worry about it. Yes, that's how it works. Yeah, this. Oh yeah, all these. Oh, there's so many. It's gonna suck. So there's one. There's one. I think pretty much all of these. There's another. And these two. That's the display stuff. Yeah, so we won't have everything routed today, but I think we'll have everything placed preliminarily, at least today. So that's progress. And then in next one, I think we should be done. Like we're clocking in 1 hour 50 minutes, so let's go for like an hour or something ish more, 40 minutes. Let's see where we get when we placed everything and how much I can get done. Okay. I still want the schematic because I want to see where things go, but I wanted to take too much of the screen because I just don't. Yeah, that's how far Windows allows me to do this. I guess that's correct. So now we hide all the bottom stuff. Okay, that should actually hide with this, yeah. Pads. And even the front silk, because this, oh no, I want, oh yeah, I can have components here. Yeah, this should be fine, okay. Looking good, all right, thank you. It's, like I said, it's actually not that many components. This board is surprisingly simple. It's just the form factor and the fact that it brings all these kind of cool things together that makes it pretty cool. And I'm really happy that will be very little software because I don't want to do software right now. So I have high hopes for this board, and now it's been covered. Adafruit blogged about it, and Hackster blogged about it yesterday, and then Microchip retweeted it today, so it's getting some traction, so that's quite nice. Which is, I like that motivation. Oops, I pressed N. 43. Oof, that's close. And also wrong. See, that's another problem that I haven't figured out yet. How close can you put a passive, like a resistor capacitor, next to a QFN before it starts getting annoying? I actually never figured it out. It just, yeah, Gorgon, I think for you, I can, if you, I don't know, what was I gonna say? Like, you will get one for sure, just so we can verify that it works properly with your board, and then, I mean, it's good press for both of us. You can say like, you can have a Linux with keyboard and display, and I can say you can have a keyboard and display with Linux. So it works for both of us. So it's in both our interests, I think. So no worries, you will get one. I just hope this works. Don't want to do too many revs here, but this is mostly verified. Yeah, so it should be fine. Yeah, Tindy is always. I've had quite a few projects that I could have sold on Tindy, but it's just like it takes time away from doing other things. But maybe that's something I need, like to not burn totally out, just to do some Tindy soldering and selling. So I would love to sell either boards or kits or even assembled ones on Tindy, and I think I will have to because quite a few people like mentioned at least they really want it. So I will definitely try my best to do it. I just have to, yeah, force myself to do that. I was also thinking of doing a stream from my hackerspace of me soldering this and then bringing up. I don't know if the bring up is gonna be interesting, but at least soldering it, just because that's always fun. Yeah, exactly. Like this, this board is not impossible to hand solder, except like I use 0603, could have gone for 0402, even though this like there's so much space. So most of this can be hand assembled by someone who, like, medium skills, because if you're used to 0805 and QFPs, you might have some problems here. But if you know how to solder a QFN, you should be good with most of these things here. The only problem is, like I say, Oh, come on. Why does it have to reload the... never mind. The connector here had assembled, but how did you... The BGA... Surely you had a stencil at least for the BGA. You can't understand the time involved in... Oh, you can understand, right. Yeah, I don't know. We'll see. I'm hoping I can definitely do something with them. So yeah, the connector here... Oh yeah, I have the super crappy model, so you can see. It's really tiny. The pitch is 0.4, I think. And it's plastic, so it melts if you touch it the wrong way. So that's the hardest one. But yeah, otherwise, like I could do assembled just these two connectors, for example, because those are the hardest. So a board with these two connectors, and then you solder everything else. That's an option, I think, and that's an option that, or maybe also this LGA, although that's optional, right? Yep. Wait. The axle, that's optional. Yeah, that's in the middle. So that's the axle. Because you don't need it. Like, it's nice to have it, but it adds to the bomb, so it's optional for sure. And it's an LGA, so it sucks. But yeah, I was saying, I'm not sure, like, this it's not too close, but could I put it close and still be comfortable with soldering this, or is it already getting too close? That's a problem I'm having always. Yeah, you definitely need hot air for QFN. If it has a pad, like you could get away maybe if it doesn't have the middle pad, but everything here does. And the LGA, you just need hot air or a refill oven. There's no way, just no way, because there's no access to the pins. Where was I? I was here. I was placing this. Then I can place this. Right, this is on test point, so that's cool. Oh, that's a sucky direction actually, so I might rotate this guy all the way around. Just thinking this has to go here and here and here. Cool. But the test points for flashing this one I probably want here, so what I'm gonna do, so I'm gonna do this. Okay, and that's pretty much it. So pin 17. Okay, now I put it too close, but that's fine. We can figure that out in a second. See, now I have to see 1, 2, 3.5 grids. 1, 2, 3.5. Yeah, because I want them to be in the same distance. It's gonna be so close here and on this side that it's great. There's a strange sound. No birds here. There's actually no background sounds in my room, at least. I'm not sure if the microphone is spiking or... I'm not sure. Maybe it's just my brain overheating. Hey, Tablatronics. Are you saying you're waving to us, or is there a wave in the background sound? Or am I supposed to wave? Woohoo. Oh, that's slow. Oh, that's really slow. No, I'm not sure. Is it because of the 3D model being gone? Yeah, something is up, and so I'm gonna save. And no waving in Kicad is too slow. Yeah, you're waving. Yeah, okay. That clears it up. This goes on 6. Oh man, this is so close. It's uncomfortably close. Yeah, I might have to put it sideways because this is just... I won't be able to fit one here. Yeah, let's see. So this one goes to 44. Right. Oh, son of a... I thought I was so clever with placing these already. So you can see here my courtyards right now, they are touching, but I have tested it with 0603, and with 0603 this is good enough. Or 0402 starts getting really close, and it's actually hard to place them because just like that, if you're between two, the tweezer actually can't fit anymore. The STM Linux board is slightly on hold right now because the chips are not available yet. I have the STM development kit on its way. Actually, they shipped it today, so I will receive that next week, and I have to verify a few things. I mean, it's nice to verify before I order and assemble a 4-layer board. So that one, it's still planned to happen. It's just slightly like I started a bit too early before I could actually get the chips and verify everything, and that's also the reason why I made quite a few PMods with like the audio and USB and charging. I was verifying each part of that design separately before I put them all together. But I want to also verify the display with that board and one more thing that I forgot right now. But yeah, I definitely want to try it because it's a very interesting chip. It's like a dual core Cortex A7 and then also a Cortex M4, which for this usage would be really nice because I could offload the keyboard stuff to the M4, so I wouldn't need this extra pin over here and that pin extra chip. So yeah, that's the status on that one. I know I kind of just stopped and it seems strange, but I am planning to keep going there. There we go. Cool. See, so this one, where the hell does it go? It goes... Yeah, it goes here. Yep. Okay. So it's so it's there, so we can get away with putting the capacitor here. Actually, even here, this could work. Has to be a bit like here, I think, because there will be traces going here. Nope, not sideways. Yeah, there we go. Okay. Yeah, so we can put the test points. Right, that's the LCD stuff. We'll get to that in a second. So TP2, TP3. There's the one, and there's the other one. I probably want to also put right next to this test points for ground and 3 volts, just so like when I'm soldering, if I make a jig, wow, these are huge. If I make a jig, then I can just connect 1, 2, 3, 4, flash it, forget about it. Yeah, exactly. It's because what is it called? The SAM A5D2C something. It doesn't have a graphics, yeah, a GPU, but the STM has. And I actually saw at the Berlin Maker Faire, there was a stand from Arrow, and they had what's it called? Boards 96, I think. They had a board from that with the STM32MP157C connected to a display and actually showing like a 3D rotating cube with some FPS and stuff. I think I took a photo. So that was their way to show that, yeah, it has 3D stuff. So that was quite nice. I don't think that board is on sale yet because the chips are not available yet. Not really, at least. So it's quite interesting. It would be also my first board with external DDR RAM, which is super scary. So yeah, that might be slightly why I'm procrastinating that one, but yeah, I will get back to it. Yeah, exactly. So I ordered it on Mouser a few weeks back, and they shipped today. So I think both Mouser and DigiKey just got the stock, so they are shipping them now. Let's see. Where should I put these test points in the schematic? Should they be here? Or should they be here? I guess they should be inside because they are related to this. Sure. Alright, let's do it. We have the ground on one side. And then we have the 3 volt right here. Okay, good. Sometimes annoy me so much. Somewhere. This doesn't it doesn't fit anywhere really, so that's the problem. Could have it. You could have it like here, but no. Just put it here and just a second, I'm getting a text, need to reply. Yeah, so what is what's happening in the chat? I always ask that question. No one ever replies. So please, like, what are you working on? What are you doing right now in addition to watching me Kicad? Like, I'm always interested in people's projects. Let me know. Maybe I can learn something from them. I know what Grogard is doing. I think you can hear my vibrating phone as I'm typing, so sorry about that. Right. By how I work with Kicad. Yeah, I actually, someone pointed out at some point that I'm pretty fast in it, and I never really thought about it, but I think I mean, when I'm not trying to get pixel perfect traces, but that's just my obsession, that's not Kicad's fault. Yeah, that's, I think. Sure. Like, I somehow over the years became really fluent without really thinking about it. So, like, all the shortcuts, it's a super time saver if you know all the shortcuts. All right, I wasn't done here. I need to annotate. How do I show the keys? I'm using OBS, which stands for something. I don't OBS Studio, and there is a plugin for it which is called Input History, where you can configure the font and where it should be and so on. So that's what I'm doing here. Because thank you, Charlotten. Yeah, Tablatronic. So it's a plugin. It's not built in. I found it on some forum. I thought it would be nice to show, so I started googling OBS and show keypads and key clicks, and yeah, there was one. So this is 3 volt. Yeah, I think I'm not sure if it's super useful to have those, but it's also like it's not bad to have them. So I think it might be useful for someone like what did he click right now? It's something happened, but then you write in the chat and it's 20 seconds later for me, and I reply and it's 20 seconds later for you, and like we lost it. So, but if you can like search back in the stream and see what I did, some crazy key chord combo that I didn't even know was a thing, then that's even better. And of course I'm using Impact because it's a meme font. Okay, so I will never ever remember the order of a ST-Link pinout. Okay, so this is clock. I need to Google this because I never remember. Right, sorry about the keyboard. I know it's quite loud, so if I remember, then I type lighter because this microphone picks up quite a lot. Yeah, so that's always, or at least usually, the pinout I'm striving for with SVD, like this ST-Link, cause the flashing, like I have this flashing board called Xil Debug, which the guys at our hackerspace and we did it, and it uses CMSys DAP, and that's the pinout we took for it. So I want to have it matching. So it's clock ground IO. So clock. So this one, and then this one. Yeah. Which sucks. Yeah. Yeah. For if you wanna get started with Sorry, just reading the comment. If you want to get started with Kicad, I can recommend. Was it Mike Watts on Twitter? Was it Mike? I think he started a series of Kicad tutorials. Like he's designing a board and describing each step and what he's doing, and they look really nice actually. So I could recommend. I don't think I'm gonna be able to find it right now. Yeah, it was Mike Watts, and if I can type his handle, it's Malthus Watts. Is that correct? Malthus? Yeah. So if you check this guy out on Twitter, I'm sure if you scroll back enough, there is a. He's gonna be talking about his Kicad tutorial. It's on GitHub, and I can recommend trying that one. We can actually align this also for no good reason. Oh yeah, I'm doing this. Why am I doing this backwards actually? Because I was doing something else. Flip. I'm gonna be super confused because it's backwards from how I was designing it so far. Right, but then it's backwards now. I have to rotate it. So that's actually way better because these can then connect directly here. And I can see these passives are way too close. Like I won't be able to route these out. Can we move them way back and then do something of this kind? Or actually these, yeah, these will have a different, they will have a different thickness of the trace because I will do them in like 6 mil. So we're there, not there yet. So right now I'm gonna just butcher this super hard. You know, this is just Kicad being silly. Oh, that works-ish. Yeah, I knew it. Now I'm confused. Like this was all flipped when I started designing it. This is not super good. Okay, so these are now, I assume, all LCD. Yep, correct. Yes, indeed. Test point. Okay, so that's right. So these test points are super random. So that's the mic test point. Oh. Yeah, there's gonna be so many traces going here. This is gonna suck. So I'm gonna move this something like this. So you solder this to enable the mic, and then the mic output is here. You can solder a wire or something. You can actually, yeah, the idea was that you could solder a wire back into the header, like into the analog in. I think these were analog out, analog in. Something like that. So you can, yeah, connect it back if you really wanted. So maybe that's fine that it's under. So far we haven't had, but it's gonna be really hard if I have to put it somewhere not under. Like what, here? No, maybe here. That's sucky. No, this is fine for now. So TP4, right? I see. Yeah. So it's gonna be somewhere here, but actually no, that shouldn't be. It shouldn't be TP. It shouldn't be keyboard. It should always be whatever is here. So it might be something totally different. So I'm gonna actually update F8. That shouldn't. Is that the net? Yeah, there we go. So now later we can deal with this. So yeah, if you missed the previous stream, this test point is for the UART. If we want to debug this this microcontroller, the UART TX is right there. So I connected to a test point so you can solder and have the UART prints as well. But right now we don't know where that's gonna go. Might actually go. Oh yeah, since I changed the chip, there's quite a lot of flexibility I can have here. Like I can just skip the pins on this side just to not pull my hair out. And that way, or actually like skip these and have these. Because there's quite a few that will be not connected anyway. Okay, and then the last one was interrupt on the expansion, on the expander. Oh, that's gonna be somewhere. I could have it there actually. Just to have it next to all the other ones. And the only problem I see here is we have to go under. Or do we? Hi, Visos here. No. Yeah, we can go like this. Yeah. Here you can see, I guess, one of the paths on the bottom, which is a bit strange. Why does it affect the top? Okay, this is fine until it's not fine, so which is the usual strategy, and usually it works out. It's fine until it's not. So now we are done with the test pads, test points, test something. We have these few fellows over here. I don't think there's a way to mass hide. I mean, I could hide them in the layer window, but that's not really hiding them. That's just hiding the whole layer. So they're still there when you do the final thing. Pin 40, pin 41. So these are definitely next to each other. Except I have no idea how to put them because I know where they go. They go right here. And I can't have them right here because the connector and the flex and all the fun stuff. And I can't have it on the bottom because that's where the display actually goes. And I don't think I can. 32, no, it's 40, 41. Oh, it's actually here. Yeah, maybe. I don't like this. Let's see how it looks on the 3D preview. It's way too close for comfort. And it would have to be something like this even because like these need to be connected actually here, which is super nice. Except that's already screwed up. Yeah, so how does this look? I should redraw the polygon fills. See, so it looks not as bad as in the actual in the 2D view. Because of the courtyards, they make you paranoid, but it is quite tight. Yeah, I think we have to do it like this. There's just no way around it. If you want to be like, proper, because they could be here, but then what's the point of them? The point is to have them super close. Yeah. Oof, no. There we go. And then you do like the 3 volt here, and then it's properly decoupled. So let's say that's alright. Kicad is having a hiccup, which always gives me a small heart attack. So that's the backlight coupled with this one. Why not? Why not? And this one as well. So it's only the pull-up that we need. This board is really simple. Like, I know it doesn't look, and yeah, it might sound strange if you are like more of a beginner, but it is really simple. Sorry to say. So where does this go? Right, this goes way here. So we can actually be super nice and just put it here, or like here-ish. Like, it doesn't have to be near the display, which is awesome. The only problem here is it's not so aesthetically pleasing. Also, I'm thinking from what's the word, like UX, like I will have the silk screen here to explain what these are, like one here and here. So having the cap in the middle of that, it's not great. See, like these are the things you have to consider. These silly things. Yeah, I mean, it's alright. Why does... Of course it annoys me that it's not perfectly in the middle here. I don't think this is in the middle either. Nope. Yep, totally worth it. Right, so we're closing on 2.5 hours. I think 30 more minutes should allow me to place this and connect some stuff, and we can call it a day. Yeah, what the heck is that? I had this bug before. Exactly, so all the vias I've been trying to place, they all ended up here. You can see them, like 9 vias. See, like as soon, like I've seen this before, and I haven't really found a fix. The only what I found was a way around it, well, like I could copy a via and just drag it, but yeah, the only fix was to actually update. So that's a strange thing. See, so nothing, no, okay, it changed slightly, because I was thinking like nothing changed up front, so there won't be any new render to make. The back though, it looks cool. In the bottom here it will be quite empty, and this is because I want the battery going here. You connect it here, the wire goes, and then you have the battery here. I think that should work out just fine. Obviously, I guess you can double tape it, but obviously without a case it won't really stay in place. Or double-sided tape it. Right. Yeah, so yeah, I guess it doesn't matter. Because what you usually want to do is you want a ground plane between two lanes that might be high-ish speed because there will be crosstalk otherwise. But right, and I just had the capacitor there. Oh, of course I did. Maybe it doesn't matter here so much because this is not gonna be super high speed. But let's leave it like this for now, just because it looks cool. Okay, so we need a decision on that one resistor, which I've now been fiddling with for 5 minutes. Yeah. Where else could it go? There's like not many places. It can go here or here. Not well. It can go here, but I don't want it there. No, those are not in the default. Fairly sure they are not. Sure, that works. Yeah, it's a custom one I made. I'm thinking because I did share something on GitHub with those buttons. I think it was a 3D model, but I'm not sure if I also shared the footprint. I mean, it's super simple footprint, just two pads. I'm not gonna check now. So no, they're not part of the standard, but I could share them if you want. Or actually, there might already be in my Kicad shared modules, like Git submodule, where I put all my modules and 3D packages, 3D models. So it might already be on GitHub. Capacitor, leave it. It's not worth it. And then we need 3 volt. We'll get to that. That's gonna be fun too. Like it's always, it's the last 5% of the traces. That's always the worst ever. So yeah, this is gonna suck also. It has to go all the way here. Wow. See, it solved itself. No, that was pretty bad. Right, the backlight stuff. Keep getting distracted. That's just how it is. At least for me, it's not a very linear process. I just do a little here, a little there, get distracted, do something else, go on a tangent, talk for 15 minutes. It's all part of the process. So this has to go right here, and that's actually fairly easy to solve. We just slap it right here. I mean, we just put it in some place that fits aesthetically, because they just go here, so that's quite nice. Except the backlight controller just goes... Okay, it goes there, so that's actually not bad. It's just gonna go way here. Yep. Okie dokie. Show me MOSFET. Yeah, that can work. That's perfect. All right, that actually concludes all the components are now placed-ish. Yeah, I'm very peculiar about my traces for no reason at all. So actually, I think it might be better to rotate this. And now for a funny footprint. Or not a footprint, whatever, a construct of some kind. And the 3 volts has to go round and round. The reset will go. Wait, what? Oh, that's just like the global reset pin. Yeah, yeah. So that has to go all the places. That's gonna be another fun one to do. Oh no, and then the. Whew. Like I can already see this has to be moved to make space for these 3. 1, 2, 3. Luckily these don't have to be connected, neither does this. So that's a lot of just dead space. So that's cool. Then all these analogs are also in the clear. That's good. There's gonna be some chaos here because the card, the LCD, and the GPIO expander have to go to the SPI. And then here we have the miscellaneous, well, the I2C, which could just go here and here. But then all the chip selects are here, and yeah, right, that's the NeoPixel. So I don't want to move these because they are on the same GPIOs as they are on miscellaneous feathers. So for example, on the LCD feather, the LCD chip select is also on like chip select and the data command. They're also 9 and 10. So it seems logical to not change those because the drivers will just work, quote, quote. Same with card and same with NeoPixel, I believe, which is just from a different board. So I really want to keep these same. I mean, if you want ecosystem compatibility, you have to go full in. There's no half-assing it. I mean, sure you could, but I don't want to do that. So let's see. Right, the card detect goes. Oh no, it goes. What else goes here? Card attack, the keyboard interrupt, which has to go all the way from here, which I guess is fine just under. And then the backlight control, which is the best one. Yeah, just let's see, do like a preliminary. Hmm. 3 volt here. Right, and the GPIO can actually go somewhere. Right, we are still, the bug is hitting again. So it can go somewhere on, like between here, that's no problem. Yeah, this is mostly doable. Then the enable has to go here. Super annoying. On the plus side, the enable can go under the SD card because it doesn't, like, it's on or off, and when it's off, everything is off. So it's not a problem to have that one be just cross the data lines. We could actually do that right now. Yeah, that's not gonna happen. Maybe I should show the, yeah. So now we're starting getting somewhere with the power domain. Right, the control, backlight control might actually be, if you PVM it, that might introduce noise, so we wouldn't really want it crossing. Excuse me, we wouldn't want them crossing this line, but these data lines, there might be no other way. These long lines. Actually, I'm curious, and obviously this is bugging out now. Yeah, so normally this should show how many you have connected and not connected and all that. Oh, that's annoying. I don't think that's actually available anywhere else except that status bar. Yeah. Wanted to see how many not connected I have, but it's a few. Not to mention all these that are literally not connected in the schematic. Right, so that's annoying as well. Probably getting on this too early. It's gonna need a lot of changes later, shouldn't get overexcited. See, yeah, there are some ways around this, but yeah, maybe that's better. Because what I can do here to actually be able to get this to work is I could do something like this, or actually here. This way I could just connect it here. Yeah, but it will cross the clock anyway, so I guess it doesn't really matter how you do it. Because see, this way I could connect the clock without crossing here, but then it crosses here. I think it's same. you know, that's an option. Can we fit it? Yeah. Alright. So this way they don't cross, at least. That's something. Yeah. And then it all goes to crap here. Yes, that's one way to do it. Kicad is sometimes way too eager. Like, I get you wanna help, buddy, but come on. Let me finish a sentence. Let me show you what I meant, and then you can maybe help. Let's see, we'll see. They still cross, but at least... Yeah, what can you do? Same problem here, and I have no idea where. I guess these have to go here, here, and then connect to these somehow. It's a shit show. Yeah, then you need a 3 volts, and here also. I don't think I ever got an answer to that while it is happening in the chat. Why does that never work? I think we could do the right. I think I will move this all the way here so I can do the resistive, the touch stuff without any interruptions. Okay, I see a problem already. Like if this one goes on the bottom, that means the next one, this one goes above it, so all four would have to be flipped to actually match here, which is super annoying. So there's no way actually around it, I guess. Because even, let me just pick this up. XM, see it's wrong, and then right, so this way it's right. So I'm reading a tweet actually. Someone tweeted at me or replied. Right. Yeah, what can I do here? I'm not sure. Could like flip them all around, but that's annoying. I don't know if I could change it on the pin out here. Because even if I can, I will have to change it in software as well, and that's a bit annoying, not being able to use the standard driver. Yes, actually, there's no. I have to do it exactly this. Yeah, that's really annoying. Because sure, I can start like this. So good so far. Except yeah, that's there. See, I fixed it, and it only took all this crap over here, which I won't be able to see because it's under the flex. Rendering. Ah, crap! I removed the corner. So why is this one marked as through hole? It shouldn't. Maybe right, because that one, because it's the same part that also has these flex. If I want to get rid of these, I also need to get rid of the what's it called? Need to get rid of the connector. Whoa, hey, yo, Kicad. This is, I know this is art, but yeah, sometimes the walk around algorithm, it really tries, like, it tries way too hard. And I mean, then it's like super happy with itself. Like, see, I meant, I found a way. You want to see the way, and the way is just, ooh, no, thank you. You know, this I don't get. Why does it have to be so annoying sometimes? Kicad gonna Kicad. See, like, okay, it pushed it, but then it should jump back if I move. Nope. Yeah, I need a new corner. Because the other one I lost in my clipboard. So it loads that step file even if it's hidden. That's something you could definitely improve. Like, it's not gonna be shown, don't load it. Yeah, I'm not super happy about this. Let's see, and let's test it and see if that causes big trouble or we can survive that. Wait, then I already, it was 0.2, wasn't it? No, 0.15, yeah. So the drill is 0.3 plus 25 annual rings, so that's 0.55. 0.3, yep. seriously. Okay, so this should allow us, yeah, there you go. So thin, so smooth. Huge via. Yeah. So if we ignore, actually we can't ignore, or yeah, we can't connect these otherwise anyway, because you need this thick, thin trace or to actually connect the connector. So no way around that. So these two are the backlight LEDs. There's like the anodes and then the cathodes. There's the row 7. Yeah. So just to get an idea of what we're dealing with is, maybe it won't be so. Like all these pins that I'm breaking out right now, they all have to go into that SAM MCU. And not only these, but also the buttons, which is 4 buttons plus the 5-way button. So that's always fun. Yeah, so all this has to go here. Under this. So annoying. I think at this point it would be better to have this be on the bottom there. Yeah. So what we do here is get rid of these. We'll deal with those later. That's fine. And now we can start connecting. So I think, yeah, these are the biggest problem from the perspective of, let me connect some grounds here. Oh yeah, one more. Yeah. So all these have to connect here, but then we also have the buttons on the bottom. Except these are, like, there's so much more space on the bottom, or yeah, well, except this one right here, but we can fix that one. So much more flexibility for these, so these could actually connect on the back here rather than these. So these are the connectors, definitely higher priority than the buttons. And so I think I will connect these and we will finish up, because we are now 3 hours 10 minutes in. I forgot to connect these. There we go. Okay, 2, 3, 4, 5, 12. And here we have 16. So actually, we are really ahead. Except the backlight control. Yeah, exactly. Backlight control has to be there as well. There's no space. Actually, the backlight control has to be on a PVM-able, PVM capable. Yes. Ah, this I'm so glad I remembered. Because not all pins on the SAM can do PVM. So I'm really glad I remembered. Isn't that convenient? Almost convenient, because I still need to flip. Why is it always backwards? Never mind. I found a way. Yeah, there's no pull-ups here, so that's why I checked here for a second that the pull-ups are on this side. And then, I mean, it's not so long, so I think it should be fine with having them here instead of here. We could have probably have them here. I don't think there's gonna be anything, or maybe there might be these going somewhere here. So yeah, let's not move that for now. Okay, so I actually have to check where can I have the backlight control, because it's not everywhere. Oof, I'm so glad I remember, because if I didn't check and it wasn't PVM capable, I would have just, yeah, had to re-spin it. That didn't open correctly. Right, so this is gonna take a second. Oh. I see the stream is having some strange issue. I think we're back now, but yeah, I think we're back. It's just saying low output, low video output, but I think we're back. Oh, I see. Oh, shit. I see the problem. Oh. Yeah. Since I'm kind of between browsers right now, it should stabilize in a second. I'm so sorry. I'm like between Opera and Vivaldi. I think that PDF tried to open in Opera and that loaded like the whole, you know, all the tabs I had, which like immediately the CPU just exploded and it took 2 gigs of RAM. So that's what took over all the CPU from the stream. So I think it should get back to speed in a second. If yeah, if you give it a second, I'm sorry. Meanwhile, I can do this boring thing of looking at PVM capable pins. Oh, this is just a summary PDF anyway. Yeah, let me know if you can hear me. I see the stream quality is like really crap right now, but maybe that's just my YouTube window. Yeah, that's just my YouTube window, I see. So hopefully it's back. I think it's still showing video output low. Hopefully it picks up in a second. Okay, this is the full data sheet, or at least the 700 pages. Sorry. That was absolute crap. This is 20G, and on 20G, as it says here, you can't use TC6 and 7, because I believe it's the TC that does the PVM, this timer comparator, was it? What is it called? Timer / counter. Yeah, that's the PVMs. Where was I? So there's a lot of pins you could actually use. I think it might be actually too many to mark over here. Works fine. Oh, okay. Sorry about that. That was. I'm really annoyed by that. Right, so pin 1 and pin 2 and 7, 8, 9, 10, 11, 12. There's either 17, 18, 19, 20. 23 up to right, not 6, so up to 38. So it's easier to mark the ones that don't work. And this is because this is gonna be more confusing than it's worth. So let's try like this. Right. We have the pinout here, or we have the backlight control, and then if we assume I just take these and go on this corner over here. So pin 19, can that do, where is it? Oh, come on. Pin 19 on G, that's TC5, 0. So that should be able to do PVM. Pin 19, all right. Let's try this. And then we go up, so we just keep going down here. So we have row 1, column 1, row 2, column 2, 3, 4, column 3, then column 4, row 3, column 5, row 4, 5, 6, 7, yeah. So that's actually perfect, because this goes here. And we could actually move this here. This way I can have the UART without having to worry about what is it called? Without having to play around with the software, because before, when I had limited number of pins, I had to choose, I couldn't use a separate pin just for the UART. So what I had to do is I had to fiddle with the software to enable the UART when I was using it, and then I couldn't use that one row or column. And then when I was done debugging, I could disable it, so I wouldn't have UART and the keyboard was fully working. But here, I can get around that. Maybe. Seems like it. So now we will have an explosion of pins. There's a ground here, and I can already see this is gonna be so. But let's worry about that in a moment. Yeah, so this is a bit boring, but this is very crucial because that's the keyboard, which is, I think, a big seller for this board. Like, displays are, anybody can do a display, but the keyboard, that's a bit interesting. Yeah, that's very nice. And then we just keep going. should save because that hiccup is... I don't know why. Why is the stream actually so slow? Like, oof. See, like I have 16 gigs of RAM. That's not bad. I have a 8-core i7 something something. This is not a bad computer. I don't know why is it so slow. I mean, the GPU I'm using is not greatest, but I don't know. Like you saw how Opera literally killed the stream. And it's the same if I'm loading. Wow, this is gonna be tight here. If I were to load all the footprints, then it would just explode. Doit. But it works. So that takes care of a lot of the connections here. So good so far on this side. I mean, you want as few as possible. It's not so bad. With the buttons we have, let's see, 4 buttons and then the 5-way, so that's 9 actually. So 1, 2, 3, 4, 5. Yeah, we'll have to get in here and just like here. But I think we'll do that on next stream. We're now 3.5 hours in and I'm quite tired actually. So I think this was quite good progress today. We started with the parts being on the side. Now we have them here. We have quite a lot connected. If only Kicad told us. We're actually gonna, if I close it and open it again, it will tell me. So 44 unrouted, which is really low number. I mean the buttons also, so that's +9. So that's 53. That's nothing, to be honest. It's just, yeah, it's always the final 5% that's tricky. See, there's the reset, it has to go. Look where it has to go. Do I have to, like, do I put it like way around here? I might have to. I guess the reset is, it doesn't have to be short. Alright. The UART we can just route here, there's the debug. Right, so the only thing that's visible is that flex. Right, because I think the flex is actually part of the connector. Because that was the easiest way to have them aligned. Yeah. If I hide the flex there, the connector is quite nice model. So yeah, next stream we have to obviously finish the routing. I need to put silk where needed, like descriptions of these parts on all the test points. And then hopefully we'll be done. Let's see it with all the models. That's gonna take a second. Yeah. Still good, still good. Nothing really changed here except, yeah, now we have the holes here. Some traces there, you can't really get around that. Yeah, I mentioned I wanted a PMOD connector, but there's literally nowhere to put it. You need this space for the battery, there just can't be anything there. Okay. Ready. Something like 1, 2, 3, 4. That's usually a good angle for taking renders. And maybe for this one it's more like yeah, no point in me like just blabbing on. So yep, that's it for today. And just save everything. Right, so thanks for hanging out with me. Sorry we didn't finish today. Sorry